Good morning, Vietnam. Today is Monday, February the 10th, 2025, and you're watching the 15th installment of the Kernighan and Ritchie challenge on my channel, Make Programming Fun Again. My name is Karol Moros, but you can also call me ChatGPT, your virtual assistant. And the goal of this series of videos is to read the book called The C Programming Language, second edition. This book was published in 1988 and has since been the go-to resource for learning the C programming language for just about 2 generations of programmers. And in the last video, we have solved the last exercise in chapter 1. And in this video, we're going to read chapter 2, called Types, Operators, and Expressions. I guess I'll just read. And when we encounter any exercises, I will solve them on screen. Chapter 2, Types, Operators, and Expressions. Variables and constants are the basic data types. They are the basic data objects manipulated in a program. Declarations list the variables to be used and state what type they have, and perhaps what their initial values are. Operators specify what is to be done to them. Expressions combine variables and constants to produce new values. The type of an object determines the set of values it can have and what operations can be performed on it. These building blocks are the topics of this chapter. Okay, variables, constants, declarations. Okay, operators specify what is to be done. Okay, yeah, this is very terse, but I think it will probably be explained in greater detail later on in this chapter. The ANSI standard. The ANSI standard has made many small changes and additions to basic types and expressions. There are now signed and unsigned forms of all integer types, and notations for unsigned constants and hexadecimal character constants. Floating point operations may be done in single precision. There is also a long double type for extended precision. String constants may be concatenated at compile time. Enumerations have become part of the language, formalizing a feature of long standing. Objects may be declared const, which prevents them from being changed. The rules for automatic coercions among arithmetic types have been augmented to handle the richer set of types. Okay. To section 2.1. Variable names. Although we didn't say so in chapter 1, there are some restrictions on the names of variables and symbolic constants. Names are made up of letters and digits. The first character must be a letter. The underscore counts as a letter. It is sometimes useful for improving the readability of long variable names. Don't begin variable names with underscore, however, since library routines often use such names. Uppercase and lowercase letters are distinct. So lowercase x and capital X are 2 different names. Traditional C practice is to use lowercase for variable names and all uppercase for symbolic constants. At least the first 31 characters of an internal name are significant. For function names and external variables, the number may be less than 31, because external names may be used by assemblers and loaders over which the language has no control. For external names, this standard guarantees uniqueness only for 6 characters and a single case. Okay, well, we haven't talked about external variables yet. Keywords like if, else, int, float, etc. are reserved. You cannot use them as variable names. They must be in lowercase. It's wise to choose variable names that are related to the purpose of the variable and that are unlikely to get mixed up typographically. We tend to use short names for local variables, especially loop indices, and longer names for external variables. Okay, yep. So this basically says, I think what this means is that the language only guarantees 31 letters of the first 31 characters of an identifier to be actually recognized by the compiler. I haven't. We could see in the C11 specification what the rule is now, but I think 31 characters is plenty for C. Section 2.2 Data types and sizes. There are only a few basic data types in C. Char, a single byte capable of holding one character in the local character set. Int, an integer, typically reflecting the natural size of integers on the host machine. I think that would be 64 bits on 64-bit machines. Float, single precision floating point. Double precision floating point. In addition, there are a number of qualifiers that can be applied to these basic types. Short and long apply to integers. Short int sh, long int counter. The word int can be omitted. The word int can be omitted in such declarations and typically is. The intent is that short and long should provide different lengths of integers where practical. Int will normally be the natural size for a particular machine. Short is often 16 bits, long 32 bits, and int either 16 or 32 bits. Each compiler is free to choose appropriate sizes for its own hardware, subject only to the restriction that shorts and ints are at least 16 bits, longs are at least 32 bits, and short is no longer than int, which is no longer than long. Okay, so all of this basically says that integer sizes are platform and compiler specific. So for this reason, we have these convenience types like int 8t, int 16t, int 32t, and int 64t, which are, I think, preferred in modern usage. So only the types in stdint, like int 16t, only these types are I think guaranteed to have properly defined sizes, and the others are, and the ones like short int, long int, they only have minimal requirements that short should be shorter than int, and long should be longer than int. The qualifier signed or unsigned may be applied to char or any integer. Unsigned numbers are always positive or 0 and obey the laws of arithmetic modulo 2 to the power of n, where n is the number of bits in the type. So for instance, if chars are 8 bits, unsigned char variables have values between 0 and 255, while signed chars have values between minus 128 and 127 in a 2's complement machine. I don't know what a 2's complement machine is. Whether plain chars are signed or unsigned is machine dependent, but printable characters are always positive. Okay, yeah, this kind of refers to the ASCII encoding where all printable characters are below 127. This is probably not so much the case for it's not so simple with UTF-8. The type long double specifies extended precision floating point. As with integers, the sizes of floating point objects are implementation defined. Float double and long double could represent 1, 2, or 3 distinct sizes. The standard headers limits.h and float.h contain symbolic constants for all of these sizes, along with other properties of the machine and compiler. These are discussed in Appendix B. Exercise 2.1. Write a program to determine the ranges of char, short, int, and long variables, both signed and unsigned, by printing appropriate values from standard headers and by direct computation. Harder if you compute them. Determine the ranges of the various floating point types. What's unit 8C? Okay, so I think we would call this limits.c, and we include standard AOH and the limits header file. We can read it by opening the file limit includes limit user include limits h, and we can search for the limits for whichever files we want, whichever we want to use. If libc use. Okay, do we have float sizes? No. Do we have int width, view int width, long width? Okay. What do you have maximum lengths? Okay. Do you have like int max? Int min? Okay. Okay, what does it say? Char, short, int, and long variables. Okay. Do I have something for short? Okay, short min and short max. Okay. So int main return 0, and this is going to be an exercise in futility basically. Or we could okay, yeah, if we really want to do it with, like the book says, so short min max. Okay. Short min and short max. Okay, let's see. I don't think this is correct. Ha ha ha. Okay, yeah, this looks correct. It says char, short, int, and long variables. Okay. Char min and char max. Char, short, int, and long variables. Okay. Then int min and int max. Okay, yes. And maybe we could make it pretty, like with tabs. And in here. Kind of, yes, well. Okay, great. And then long, okay. Long min and long max. Okay, well, LD. Yes, that could be correct, I guess. Okay, great. Not this one. Signed and unsigned. Okay, then we do the same for unsigned unsigned types. Or yeah, maybe normalize f. And uchar, yeah, basically just uchar. Okay, it looks like for assigned integer types there is no minimum value. Char unsigned, because for everyone the value is, for every unsigned type the minimum value is 0. So unsigned short, unsigned int, and unsigned long. And let's see. Yes. And for unsigned int, the maximum should be an LD type. Okay. Is this an LLD type maybe? Okay. That's kind of embarrassing, but I don't know how to print an unsigned long value with sprintf. I'm going to have to Google. Or maybe I could just open up the printf documentation, right? Wait. Print, no, not this one. Wait. Okay, yes, this one. So this is the documentation for printf from the standard library. And okay, yeah, let's see. Oh, you know what? Maybe I could just integer. Okay, yeah, well, I'm afraid we're going to have to read it. The format string is a character string beginning and ending in its initial shift state, if any. The format string is composed of 0 or more directives, ordinary characters, not %, which are copied unchanged to the output stream, and conversion specifications, each of which results in fetching 0 or more subsequent arguments. Each conversion specification is introduced by a character % and ends with a conversion specifier. In between, there may be, in this order, 0 or more flags, an optional minimum field width, an optional precision, and an optional length modifier. The arguments must correspond properly after type promotion with the conversion specifier. Okay, so let's assume this is a long unsigned, right? Okay, yeah, that kind of looks more correct. Yeah, that kind of looks like the double of the number above. Okay, and I'm going to add some more tabs to make it pretty. Okay. Yeah, okay, and I'm going to add some more tabs here to make it even prettier. Yep, looks just about right. Determine the ranges of the various floating point types. Do we have something for limits? Like, I don't think there are any limits here. Sizes of integer types. Are there any other? What do you have in user include? Do you have something like float? No. Numeric limits. Okay, yes, so apparently there is an FLT max and FLT min, and it's so min equals this and max equals this, and that would be FLT min and FLT max, and I want to use float.h, not cfloat. Okay. not sure about it. Could be. How many bytes is that? Anyway, double for double. And double max. I don't know. Yes, maybe. This looks pretty long. I'm not going to complain, but I don't think we need to care about these. Just how long is this? Well, yes, whatever. I don't think it matters. Let's just remember that float and doubles hold long numbers. Okay, section 2.3, constants. An integer constant like 1, 2, 3, 4 is an int. A long constant is written with a terminal L or L, a lowercase l or uppercase L, as in 1, 2, 3, 4, 5, 6, 7, 8, 9 L. An integer too big to fit into an int will also be taken as a long. Unsigned constants are written with a terminal U or U, and the suffix UL or UL indicates unsigned long. Floating point constants contain a decimal point or an exponent or both. Their type is double unless suffixed. The suffixes F or F indicate a float constant. L or L indicate a long double. Okay. The value of an integer can be specified in octal or hexadecimal instead of decimal. A leading 0 on an integer constant means octal. A leading 0x or 0x means hexadecimal. For example, decimal 31 can be written as 037 in octal, and 0x1f or 0x1f in hex. Octal and hexadecimal constants may also be followed by L to make them long and U to make them unsigned. 0xFUL is an unsigned long constant with value 15 decimal. A character constant is an integer written as one character within single quotes, such as single quote x single quote. The value of a character constant is the numeric value of the character in the machine's character set. For us, it's going to be ASCII. For example, in the ASCII character set, the character constant 0 has the value 48, which is unrelated to the numeric value 0. If you write 0 instead of a numeric value like 48, but depends on the character set, the program is independent of the particular value and easier to read. Character constants participate in numeric operations just as any other integers, although they are most often used in comparisons with other characters. Certain characters can be represented in character and string constants by escape sequences like \n, new line. These sequences look like two characters but represent only one. In addition, an arbitrary byte-sized bit pattern can be specified by \000, where 000 is 1 to 3 octal digits, 0 through 7, or by \x hh, where hh is 1 or more hexadecimal digits, 0 through 9, A through F, or capital A through capital F. So we might write define vtab 0 \013 ASCII vertical tab define bell 007, or in hexadecimal define vtab \xb or and bell \x7. The complete set of escape sequences is \A for alert, \B for backspace, \F for form feed, \N for new line, \R for carriage return, \T for horizontal tab, \B for vertical tab, \/ for a literal backslash, question mark for a question mark, single quote for single quote, double quote for double quote, and arbitrary characters with \O, three octal digits, or \X and double hexadecimal digits. The constant character \0 represents the character with value 0, the null character. \0 is often written instead of 0 to emphasize the character nature of some expression, but the numeric value is just 0. A constant expression is an expression that involves only constants. Such expressions may be evaluated during compilation rather than runtime, and accordingly may be used in any place that the constant can occur, such as in define maxline 1000, charline maxline +1, or define leap and blah 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 blah, the calculation of months in a year. A string constant or string literal is a sequence of 0 or more characters surrounded by double quotes, as in double quote I am a string, or an empty string. The quotes are not part of the string but serve only to delimit it. The same escape sequences used in character constants apply in strings. \double quote represents the double quote character. String constants can be concatenated at compile time. Hello world, like this, is equivalent to hello world. Hang on, I'm going to take a break here. Yes, I'm back. Where were we? The quotes are not part of the string but serve only to delimit it. The same escape sequences used in character constants apply in strings. Double quote represents the double quote character. String constants can be concatenated at compile time, like this. This is equivalent to this. This is useful for splitting long strings across several source lines. Technically, a string constant is an array of characters. The internal representation of a string has a null character \0 at the end, so the physical storage required is one more than the number of characters written between the quotes. This representation means that there is no limit to how long a string can be, but programs must scan a string completely to determine its length. The standard library function strlen returns the length of its character string argument s, excluding the terminal 0. Here is our version. Okay, I'm not going to implement it because we have strlen in the standard library. strlen and other string functions are declared in the standard header string.h. Be careful to distinguish between a character constant and a string that contains a single character. The character x is not the same as the string x. The former is an integer and used to produce the numeric value of the letter x in the machine's character set. The latter is an array of characters that contains one character, the letter x, and a null terminator. there is one other kind of constant, the enumeration constant. An enumeration is a list of constant integer values, as in a Boolean no yes. Wow, this is such an old style Boolean. The first name in an enum has value 0, the next one, and so on, unless explicit values are specified. If not all values are specified, unspecified values continue the progression from the last specified value, as in the second of these examples. Okay, yep. Like this, yes, so you can define a month enumerations, and you only define the first value and everything else will follow. Names in different enumerations must be distinct. Values need not be distinct in the same enumeration. Okay. Enumerations provide a convenient way to associate constant values with names, an alternative to #define, with the advantage that the values can be generated for you. Although variables of enum types may be declared, compilers need not check that what you store in such a variable is a valid value for the enumeration. Nevertheless, enumeration variables offer the chance of checking, and so are often better than defines. In addition, a debugger may be able to print values of enumeration variables in their symbolic form. Okay. All variables must be declared before use, although certain declarations can be made implicitly by context. A declaration specifies a type and contains a list of one or more variables of that type, as in int lower upper step, char c, line, and this line is actually a different type because it's an array, and this was section 2.4 declarations. Variables can be distributed among declarations in any fashion. The lists above could equally well be written as int lower, int upper, int step, char c, char line, array 1000. The latter form takes more space but is convenient for adding a comment to each declaration or for subsequent modifications. A variable may also be initialized in its declaration. If a name is followed by an equal sign and an expression, the expression serves as an initializer. Why didn't you tell it to me later? I thought it was not permitted in NCC. Well, okay. Char escape is \, int I is 0, int limit is max n plus 1, float EPS. Okay. If the variable in question is not automatic, the initialization is done once only. What's an automatic variable? The initialization is done once only, conceptually before the program starts executing, and the initializer must be a constant expression. An explicitly initialized automatic variable is initialized each time the function or block in it is entered. The initializer may be any expression. This sounds vague. An explicitly initialized automatic variable is initialized each time the function or block in it is entered. The initializer may be any expression. External and static variables are initialized to 0 by default. External and static variables are initialized to 0 by default, like in Go. Automatic variables for which there is no explicit initializer have undefined values. The qualifier const can be applied to the declaration of any variable to specify that its value will not be changed. For an array, the const qualifier says that the elements will not be altered. Const double E equals this. Const char message array equals warning. The const declaration can also be used with array arguments to indicate that the function does not change that array. The result is implementation defined if an attempt is made to change a const. Yes, so you can specify an argument to a function as a const, and the C standard does not guarantee what will happen if you try to modify it. Section 2.5 Arithmetic operators. The binary arithmetic operators are plus, minus, asterisk, and slash, and the modulus operator %. Integer division truncates any fractional part. The expression x %y produces the remainder when x is divided by y, and thus is 0 when y divides x exactly. For example, a year is a leap year if it is divisible by 4, but not by 100, except that years divisible by 400 are leap years. Therefore, if year is divisible by 4 and year is not divisible by 100, or if year is divisible by 400, this is a leap year. So this happened recently in the year 2000. Yep. The % operator cannot be applied to float or double. The direction of truncation for slash and the sign of the result for % are machine dependent for negative operands, as is the action taken on overflow or underflow. Sorry, excuse me. Yeah, this is kind of vague for me, at least, and I don't think I'm going to wonder too much about what this means until I need it. The binary plus and minus operators have the same precedence, which is lower than the precedence of times, division, and %, which is in turn lower than unary plus and minus. Arithmetic operators associate left to right. Okay, this is basically the operator precedence as defined by mathematics. Table 2.1 at the end of this chapter summarizes precedence and associativity for all operators. 2.6 Relational and logical operators. The relational operators are greater than, greater or equal, greater than or equal to, less than or equal to. They all have the same precedence. Just below them in precedence are the equality operators. Equals or does not equal. Relational operators have lower precedence than arithmetic operators. So an expression like I is less than limit minus 1 is taken as I is less than limit minus 1, as would be expected. More interesting are the logical operators and or. Expressions connected by and or are evaluated left to right, and evaluation stops as soon as the truth or falsehood of the result is known. Most C programs rely on these properties. For example, here is the loop from the input function getLine that we wrote in chapter 1. For I equals 0, I is less than limit minus 1, and C equals getChar is not a new line, and C is not end of file, plus I. Before reading a new character, it is necessary to check that there is room to store it in the array S, so that as I is less than limit minus 1 must be made first. Moreover, if the test fails, we must not go on and read another character. Similarly, it would be unfortunate if C were tested against end of file before getChar is called. Therefore, the call and assignment must occur before the character in C is tested. The precedence of AND is higher than that of OR, and both are lower than relational and equality operators. So, expressions like this one need no extra parentheses. But since the precedence of does not equal is higher than assignment, parentheses are needed in C equals getChar is not equal to new line to achieve the desired result of assignment to C and then comparison with new line. By definition, the numeric value of a relational or logical expression is 1 if the relation is true and 0 if the relation is false. Yeah. The unary negation operator exclamation mark converts a non-zero operand into 0 and a 0 operand into 1. A common use of not is in constructions like if not valid, rather than if valid equals 0. It's hard to generalize about which form is better. Constructions like not valid read nicely, but more complicated ones can be hard to understand. Exercise 2.2. Write a loop equivalent for the for loop above without using and or. Yeah, I guess this is an exercise in futility. That's getLine, right? Yeah, I guess we have to do it in like, or maybe I think it said something like so while I think we could do it something like this. While I is less than limit -1, if C equals get char is a new line break, if C equals end of file break, something like this maybe. And then yeah, so the exercise only specified but we have to write that particular loop without and or operators. So char line, yeah, define a limit at 1000 characters, char line max. We're not going to get too deeply into the specific exercise, I guess. Is not greater than 0. Okay. Printf line and int length. Okay. Yeah. So basically, this would be a poor man's like a program echoing the input, and it's called no end. So no end on its own source code. It reads only with wait. Why did it only output the... Oh yeah, because the second line is empty. So yeah, we want to include the new line as well. SC is equal to this maybe. No, maybe here, like so. Oh, great. here. Okay, I'm kind of at a loss. I don't think this matters so much. I mean, it does, but we do want to output a new line. So maybe like this. Yeah. And like this. Yeah, that makes more sense. Yeah, whatever. Type conversions. When an operator has operands of different types, they are converted to a common type according to a small number of rules. In general, the only automatic conversions are those that convert a narrower operand into a wider one without losing information, such as converting an integer to floating point in an expression like f plus I. Expressions that don't make sense, like using a float as a subscript, are disallowed. What does this mean? Expressions that might lose information, like assigning a longer integer type to a shorter, or a floating point type to an integer, may draw a warning, but they're not illegal. A char is just a small integer, so chars may be freely used in arithmetic expressions. This permits considerable flexibility in certain kinds of character transformations. One is exemplified by this naive implementation of a function a to I, which converts a string of digits into its numeric equivalent. I don't even want to look at it. As we discussed in chapter 1, the expression s of I minus the char literal 0 gives the numeric value of a character stored in s of I, because the values of 0, 1, etc. form a contiguous increasing sequence. Another example of char to int conversion is the function lower, which maps a single character to lowercase for the ASCII character set. If the character is not an uppercase letter, lower returns it unchanged. It's not okay. If C is between capital A and capital C, return. Yeah, that makes sense. This works for ASCII because corresponding uppercase and lowercase letters are a fixed distance apart as numeric values, and each alphabet is contiguous. Each letter is contiguous. Okay, yeah. This latter observation is not true for the EBCDIC character set, however, so this code would convert more than just letter in EBCDIC. Whatever EBCDIC is, it's non-ASCII, and it's 2025. We just pretend only ASCII exists. The standard header ctype.h described in Appendix B defines a family of functions that provide tests and conversions that are independent of character set. For example, the function to lower c returns the lowercase value of c if c is uppercase, and so to lower is a portable replacement for the function lower shown above. This test can be replaced by isDigit. Also, we have reached the 1 hour point of this video, so I'm going to wrap it up for today. I hope you learned something from me reading this book. And if you have enjoyed this video, please consider liking and subscribing. It really goes a long way for these likes and subscribes really go a long way with regard to the algorithm, and I will see you tomorrow.